Okay, this is Karen O'Brien, and we are going to continue our investigation into how to split up domains. And I always want to start this off by saying that this particular project is not that large. So in reality, I wouldn't split this up. I would just let this go ahead and be a single model. It's about 1.6 million 20-foot cells. But it's great example for splitting up a project because it's kind of got some features that that we can review to see how to split. So last week we split our this is the full domain in red down here. You can't probably see the whole thing because it's being covered by a lot of stuff, but the full domain, I just ran that full domain, and then that gave me a depth, and sorry, I actually ran that as a time series output so that I could see how the water crossed over between the two hydrographs. And just to remind you how I did that, I grabbed that data from, if you go into the runs, I grabbed that data from the full grid, and the first grid is a 50 by 50. And I grabbed that using the depfp.out file. That's just a pointer file to point it to that folder. Then you can click add and then close. And then you get here your, whoops, where is it? It's right here. You get here that the results. And then I think what I did is I added a style to that. But before we do that, let's just switch that over here to the depth, the flow depth. And the flow depth is time variable. So if you use the time control bar right here, you'll hit this button here to start it or to activate it, and this button here to set the range. Then you can control the depth. Let's make sure it's on top of everything. Hang on a second. Maybe I didn't do that one. Did I actually click that button? And then you can see that this is your flow depth as the water progresses. So you'll need to, when you have that in here, you can see over here that I've got that on flow depth, but then of course, I need to clip out some of this data. Okay, and so you can see as this water flows and recedes, you can kind of see where is it crossing the boundary. And we want to use our this map to kind of help identify what is the best place to locate a boundary. And then because you don't want your boundary in a very complex area, you want it in kind of an area where the water is just kind of clearly crossing the boundary. It's not ponding, it's not swirling around, it's just crossing the boundary. And you can also use your velocity vectors for that. Let me turn those on real quick. And zoom in along your boundary. And as you move your mouse, or excuse me, this control bar back and forth across the boundary, you can kind of see where things clearly cross the boundary. And in our case, we used this large highway as our boundary because that kind of a nice block, that stopped or that controls the water from one side to the other anyway. So I chose that as a boundary. A couple of things to note that you might not want to do. You might not want to make a boundary that is like, you be careful about storm drains. Sometimes if a storm drain, like a main trunk line of a storm drain, has to cross a boundary, the way that you're going to have to set that up might be a little bit weird. Because like, say if I were to stop, like, so say I had a trunk line coming down this road right here, and it crosses my boundary right here and just keeps continuing down to the drainage at the river. How do you assess the slope and the length where you're cutting this off? Because that's going to change, like you're changing the length of that pipe as it's moving down across that boundary. So you might find that you have to artificially adjust the length and the slope of the pipe right here so that the water keeps continuing downstream, and then and maybe artificially adjust the length of the pipe on the downstream model as well. So I would say be careful about main trunk lines crossing boundaries. Try to keep your boundaries in a manner that something like a storm drain main trunk line doesn't have to cross that boundary. It's not always possible, but just be careful about it. All right, and then we also have this channel down here. So we're gonna set that channel up in these two domains and show you how to do that a little bit today and a little bit next week. So today we'll focus on, last week we split this into a north and south boundary, and we used this boundary control to define the control between the two. So if you look at this, sorry, let me grab these guys right here. I'm going to turn on the computational domain, and I'm going to turn on the full domain, and then I'll turn everything else off. And let's just turn the boundary off for now. And then we'll get into here, and you can kind of see that we have 3 polygons now. Let me see if I can maybe get rid of that. Let's see. Okay, here we go. Great. I have this one. We have the southwest polygon, the southeast polygon, and the full polygon. And we have the computational domain from last week. Okay. So last week we did something like, let me turn this off real quick and unselect everything. Last week we did the computational domain and the south domain. Oh, dang it, it was a scratch layer, so it's gone. And we used we used the grid to cut our south domain and create our south domain. And what it ended up looking like, I'm going to turn these two back off, is this right here. Let me select this guy one more time. Right here. It ended up looking like a domain that just overlaps the northern domain by a single grid element. So the grid elements down here in the south were 20 feet. The grid elements up here on the north were 60 feet. If you do split these domains and you're not going to use the same grid cell size, make sure that your downstream grid size is at least like a multiple or a factor or something like that, so that they'll fit inside them. So then you can see here that because this one was a 20, I just raised the position of this up so that we overlap by 1. And that means that these outflow nodes will become the inflow node at the downstream domain. So this outflow node from the upstream domain is going to calculate a specific discharge, and then it's going to divide it by 3 and split it into the 3 inflow nodes for the south domain. Now, a couple of you had also mentioned, what about when we have a diagonal flow or something like that? And I'm not exactly sure what to tell you about that, other than, if your 2 projects are the same size, that might work for you. But if they're not, that won't. So that's why I kind of try to identify locations where the water is kind of clearly crossing, in a predominant direction. In this case, that's predominantly south. And we are, regardless of whether or not we're getting the exact diagonal flow or whatever, we are definitely getting the total volume. And of course, remember that as soon as this water, crosses this domain divide, you're kind of losing things like, your velocities and your momentums and things like that. They have to be reestablished on the secondary domain. So keeping that in mind when you build domains. Now, so we did all that last week. And what I wanted to do this week was to just do this process again, except we're going to modify 2 different domains. So what I have here is this boundary condition, and I need to kind of split it into 2. So we can do that in a couple of different ways. Depending on the complexity of your boundary, you might want to use like a split tool, but Our boundary is not very complex, so we can probably just modify it or make a different one. So if you wanted to split your boundary, let's see, if you wanted to just like split this boundary polygon because it was really complicated and you didn't want to redraw it, you could probably just split it into two using the edit and then using this this splitting tool right here. But because it's pretty simple, I think we can just rebuild it. So the first thing I'm going to do is, first off, I'm just going to turn the editor off. We don't need to see it. I also want to unselect everything. We don't need to have things selected. And instead of doing that, I'm going to create a new polygon like here, and I'll just copy this guy. Let me see, let's turn off the grid. Maybe turn off the grid for just a second because I don't want to snap to the grid. So I'll just snap to this guy instead. And you can see here, and then gonna get, let's see, the end of my boundary is right here. So I'll go right around in here. Whoops. Yeah, no, that's fine. That's fine. That's fine because, and then this, let's see, this should probably be good enough. Then we'll go down here and pick up the rest of this boundary, or sorry, excuse me. What we're after is just kind of copying this boundary polygon. I'm going to right click it. Now I've just made a new polygon that kind of covered that other one. I'm going to right click it and set this to outflow, click OK. Then I'm going to click save. And I want to go to the outflow side and make sure that outflow, let's see, which one are we on? This is outflow 3. This becomes the type 4, and this becomes either 1 or 2. So I think originally I had set this outflow 2. Let's see, where is that? Let's make sure and grab, yeah, let's grab that. This one will set to 1, and outflow 3, let's call this, let's name this so we don't confuse them. This will be the southwest domain or southwest outflow or boundary. We'll just call it southwest. And let's grab this one and let's call this one southeast. Or you can actually even name it like the name of the domain or whatever you want. Now what we have to do is just modify the southeast polygon. So I'm going to grab the boundary condition editor here, click the editor pencil, and then I'm going to use the vertices tools to delete. Yeah, it should be okay. Let me put one right. Wait a second. I want to make sure that I'm deleting it from the right polygon. So hang on a sec, because I'm actually able to delete both of them. So let me use the move tool real quick. Yeah, we want to move this one. Nope. Control. Yeah, we want to move this one. Let's just get it out of the way for a sec. And then we'll use these tools here to get rid of some of these vertices and reposition the ones that we want. Okay, so that's somewhere in here. And then we can delete these two and pull this one down here. Whoops, I didn't grab it. And then now we just need to move this guy back. Make sure you're on move this guy back, and then we'll just make sure that they kind of line up better on the grid. We want to make sure that we have them lined up where we want them. Okay, we're still on move. I'm going to get off snapping tool right now. And that should be pretty close. Like, let's see, let's do it like right here. And then we'll blend this one down here. Okay, and now we have two distinct boundaries. We have the southwest the southeast, and each of those will feed a different subdomain from downstream. So I'm going to save that, whoops, and turn off the editor, and then I will need to calculate this domain again. So this can take a bit of time. So this one is 1, southeast is 1, southwest is 2. Now, if you're using an older version of Build 21, be aware that if you get an error about the boundary, be aware that this needs to be like the arrays where something was wrong with the arrays. So you might need to start with 0, 2 and just leave 0, 1 out. But it doesn't matter for the build I'm using. Okay, I'm going to just use the schematize tool. We should be ready to go. And that is going to take some time. And then Ryan, so while we're waiting for that, we'll answer some questions. So Ryan says that you said the flow has to be reestablished in the new domain. Yeah, Ryan, you're going to have to, I don't know about that, because I think that Jim has thought about that and, considered doing that to, keep the velocity or keep the momentum or keep the velocity in the equation, but he hasn't done it yet. So maybe send him an email, or we can maybe send Jim an email, but I don't know. Okay, so now that, actually that didn't take that long at all. So now if you come in here, you should see that you indeed have, these boundary conditions in both of the domains. Now let's export that. Let's see, we need to export. First of all, let's check and see our conditions. We have a 10-hour run, half-hour interval, rainfall. And remember, I didn't use any infiltration just for the setups, but if you guys put your infiltration in right away, that's perfectly fine. I used a fake rainfall because I didn't want to run it for very long. And I used a zero infiltration because I didn't want to, I want to just see the water crossing the boundary. But however you want to set that up, your initial run, you do it the way that you feel comfortable. And then I did use this time series output so that we can see the water crossing the boundary. Now, the only thing different in this one will be the this outflow nodes should now be set. These ones will be 0, 2, and these ones will be 0, 1, and these ones will be regular outflow nodes. So let's go ahead and export just what we need into our run. So here's our runs, and I don't think I want to overwrite this. So let me maybe just say, let's just call this North 60 with 2 domains. Okay. And we do not, oh, I didn't mean to check that infiltration switch. Hang on. Let me go sort that out. I didn't mean to check. Oh, it's not checked. Okay. I don't know why it told us that it needed, or that I know we don't have any infiltration in here, so I don't know why it gave us that message. Unless I no, I don't think I calculated any infiltration at any time. Okay, then we go to runs, and this is the Northgrid 2 domains. Select the folder and outflow. That's what we want, and everything else is fine. Click OK. And now we'll go to that folder. First of all, I'm going to get the engine. This is the Build 22 engine. It's going to be released probably in the next week or two. I would say 2, because I don't really, I still have to finish up the manuals on that, but I'll do an announcement on that a little bit later. And then that was the Northgrid 2 domains. So what we have in here is, let me sort that by type. What we have in here is the cont.dat. We're just going to check that real quick. Ignore this. This is coming from QGIS. I don't know why that's writing this. This is not really accurate. So just ignore this right here. Then we have 10 hours, half-hour run. We only have rainfall as a switch, and then we are running some time series output. Everything else is pretty much default. Okay. And this is what we changed. So now these are the nodes that are just general boundary conditions that just leave the grid. we have the O1 to feed the southeast domain, and we have the O2. Oh, where's our O2s? Hang on, maybe I messed that up. Southwest. Sorry about that. I did mess that up. And then southeast is O1, southwest is O2. So we're gonna have to do that again. Sorry about that. Okay. So while that's processing, and we'll go and look at the other two domains. So this is the southwest domain. And for this one, what I did on this one is I built my channel, but I didn't schematize it. So I built I set up this, in the south domain, I set up the whole channel, but I didn't schematize it. And then I split the two, and then I just deleted out the parts of the channel that I didn't need. So that's why this one starts at cross section 27 and goes to cross section 46. And the southeast domain starts at cross section 1 and goes to cross section 27. But I'm not going to focus on the channel right away. What I'm going to focus on is the fact that I took this domain and I basically split it. Well, let's just take a quick look at the southeast real quick, okay? So here's the southeast. Of course, it's just called south domain because I just edited the south domain. And while that's loading, I'm going to export this one more time. So that's North Grid 2 domains. Uncheck that. And now we can check that outflow.dat file real quick. South, north, outflow.dat, and make sure that that now has some O2s. Yes, and there's our O2s. Okay, so now we have a boundary that will feed two domains. And the next thing that we need is the CAD points from both of those downstream domains put in here and then run it. And we're going to do that now. And then we'll go look at the other two domains. I'll show you how we created them. So we need the south domain CAD points. I'm just going to make a copy of it. I'm going to call this CAD points. Let's see, this is southeast. So this is DS2 underscore DS2 dot dat. I'm also going to have to double check that I named that correctly. And then that goes in here. That goes in the north domain. Now we have to get one more. Okay, we have to get southwest. So this one is CAD points DS1. Whoops. .dat. Copy. And this one also goes in here. All right. Now I'm just going to check real quick just to make sure that I named that CAD points file correctly. CAD points underscore DS. Yeah. Okay. So let's go ahead and go back here. Now we have CAD points DS1, CAD points DS2, and when we run the model, it will create the CAD points for, this regular run. We checked our rain was 4 inches of rain over 6 hours, and I don't have any interest in any of these other files because we're just using this to establish the boundary control. And then when we have the boundary control, then we can start doing things like adding infiltration and making sure the rain, making the correct rainfall and adding and adjusting end values and things like that. But for now, we're just getting the boundary to work. Okay, so now we start this, and this should take about 20 minutes, but we don't have to run it the whole way. We'll just run it until, okay, so now it's going. And what it's doing is as soon as that water from this rainfall starts to hit the boundary, it's going to fill up inflow nodes for the two downstream domains. You might be able to see them. Nope, they're not going to be written till the very end, the two inflow nodes. Okay, so now let's go and look at the other two projects. So let's remove unavailable layers. And I'm going to slow this down a little bit, slow my talk down so that I don't want to, you know, confuse you about this next process. Why is this taking so long? Something missing? Sometimes I lose something. Nope, nothing's missing. It's just taking a while. Oh, wait, maybe something is missing. Nope, that was the other. That was the north domain. Okay, it worked. It's in now. Okay, so now this is loaded. And let's see. I want to just talk to you about how I set these two domains up. So I started with, in this case, I started with the entire south domain, and I just created a blank geo package, and I imported the whole south domain into both layers, right? So it was here, south domain, but also when I started the southwest domain, I did the same thing, right? I just took I built myself a new geo package, a new blank geo package using this process, and I called it Southwest Domain. I'm going to cancel that because I don't want to do that right now because it'll put it on the map and I don't want that. So I built an empty blank geo package called Southwest Domain, and then I imported the full complete south domain into it. And then I just started to isolate out the stuff that I didn't want. So let me take a quick look at so you can see the original full project. Let me grab a shape file. So south domain is south domain clipped. That's the one we want, south domain clipped. Okay. So this is the, excuse me, the original full shape file, south domain clipped. And basically what I did is I took, in order to create the other two domains, is I took the computational domain layer and I just selected all of these vertices in the computational domain layer and I deleted them up to a specific point that ended at like a single cross section. And what I'm going to do now is I'm going to kind of zoom both projects in so that you can kind of see that these two, and I'll try to get this so that we can kind of go back and forth between these two. And you can kind of see that this cross section, whoops, sorry. This cross section right here is this is cross section 27 is the same exact cross section 27 in the downstream model. So they're the exact same cross section 27, okay? And let's see. And then the domain, as far as the computational domain goes, I just cut out and made them overlap by 1. So I'll show you this in just a second. I'm going to take this one now, the south domain. Oops, sorry about that. I have a meeting. I'll have an alarm on so I don't miss a meeting after this. Okay, so let's take the southwest here. You see here, and I just, again, overlapped it by a single shapefile. Ooh, I hope I overlapped it. Oh yeah, I did. Let's see, because it's covering it. So let's put it under the computational domain. Oh, it's right here. See, so I just overlapped it by a single grid element. In this case, it's just a single grid element. And then in this one, I also am going to have water. Not only am I going to have water crossing this domain, but I'm also going to have water crossing this domain. So in this case, I have to run the north first, then I have to run the southeast, and then I can run the southwest. So what I did on this one is I made another boundary condition along this boundary. They're not typically this complicated, but this was just the only way that I could do this. with hydrograph 401. So now what we'll need to do on this one is when we export this, we will need to put, let's take a quick look at it. The southeast domain, we need to get, wait, doing that wrong. Oh, did I totally screw that up? This one was supposed to be DS2. You guys, I totally screwed that up, didn't I? I apologize for that. Hang on, we're gonna have to kill this. Oh, it was done too. What a bummer. Okay, bear with me. I apologize for that. I think I named those backwards because the southwest should have been DS2. Okay, that'll be closing in a minute. Okay, let me go back here. Yeah, that's why there's no inflow for the other one. Okay. All right, so let me delete that. Come on. Okay, there we go. All right, I'm going to delete that. And I think I messed these up. So I'm just going to, and then I'm going to actually, you know what? Let's just do this. I'm going to pop this over here. I'm going to pop southeast, open in a new window right here so that we don't get lost. And then I'll pop southwest down here. It'll be a little bit. And now, so southeast should be DS2. And southwest, nope, I'm screwing this up again. Yeah, southeast should be DS1. And get that back in here. And southwest should be DS2. Yeah, I had those backwards. I do apologize for that. I'm going to have to run this one again. Okay. And then I think when you start it, or after you start it, I believe you can check these guys. Well, maybe you have to wait till it's done, but you can check these guys to see the connectivity when they're done to make sure that you did that right. Okay. Now, sorry about that. Okay. Now let's get back here and we'll talk about the next one. So now what we need is the CAD points. We need this CAD points right here. And we're going to call it CAD. We're going to use the DS2 because, well, actually, no, I'm not, because that's going to take forever. So this, when this runs, it's going to need the CAD points from the southwest. So that's going to be, it takes a really long time to compute this boundary because these are so small. So I'm not going to reset that to 1. I'm just going to put it in here. So we have north. Let's minimize this so it's not such a pain. Okay. And southeast and southwest. And what we need is we need to feed this guy in here. And then I'll just delete that. And then this will be, I'm just going to put this in here, but I'm going to make it slightly different. Okay, just so that we don't forget that this one goes over here. So definitely better to have QGIS do all of this. And that's why I'm working through this process, is to learn how to get QGIS to do this. Okay, now that we talked about how to set it up, what do we need? We need the CAD points. We got that. We got the southeast model. Needs the inflow from the northeast model, which it already has. So we could get this one running right away because it already has the inflow from the northeast monolith. Well, no, it's probably wrong. Yeah, it's definitely wrong. So we'll definitely re-export the whole thing. So let's see. Let's take a, no, it actually is right because I already did it. So what I did on my, let's focus on the southeast domain right here. So what I did after I split this into its own is I recalculated the grid, I reset the elevation, and then I deleted out all of the inflow nodes in this area, like the ones that were for the downstream model. I deleted them all out. So then I just exported this, and these inflow nodes come from that north domain, or you can get the new ones that we're calculating right now. And then you get this boundary becomes inflow nodes for the south domain, but you also need to add in the inflow from this channel, but we're not going to do that right now. We're going to work on that next week. So then I split my channel up at cross section 27. Everything downstream I deleted out of this domain. And then on the other one, everything upstream I deleted out of this domain. Or I deleted out of this domain. So you can see that the channel splits right here. And again, when the water is moving through this system, you are going to lose that momentum at this boundary. So make sure to make this boundary at a location where you're okay with that. Boundaries are kind of sacrificial areas. So the water will take a bit of time to fill this back up before its momentum and velocities and everything kind of build back up in the right direction. But since you start at 0 times 0 discharge, everything kind of goes fairly well organized as it crosses the boundary. Okay, so let's see where we are. We need this to run, at least 10, well, we can run it for around 10 hours. It peaks at 6, but you run it for around 10 hours and then check out the inflow hydrographs for those other 2 domains. Now, while we're waiting on that, what else can I tell you? I think that's about it. Just bear in mind that your domains should not be this complicated. I'm just trying to do this so that I can show you, how a channel works across a boundary and how to split up multiple domain into multiple boundaries. But I didn't expect to have to feed, this domain into this domain. I would never do that in a real project. That's just too complicated. But in our case, because I wanted to show you how to split a channel up, I ended up having to do that. All right, so we're about at the peak. Let's just go ahead and stop this just so that you can see what it created in the downstream direction. I'll go ahead and exit out of it. It's going to write all of its output file, and it's going to write the 2 inflow.data files up to 7 hours. So we have to wait for those to finish. It actually takes a bit longer, I think, to do this export process because of the domain. So it might add a bit of time. Not only is it printing out the time series output, it's also calculating the inflow across those boundaries. So that's probably why it's taking a bit more time than normal. Let's see what's in here. So now what we should have is, this is the inflow for the downstream. You can see this one is the inflow for the 2 inflow nodes. And then now they should have their full data. And you can see that it only goes to 6.5 hours because I only ran it to, like 7 hours. So each one of those for the east. And again, this and these 2 go together, and these 2 go together. And then this one for the west. And now I had them backwards before, so all of these would have been 0 before in my previous run. Okay, now let's take this and let's put them where they're supposed to go. So I'm going to copy the east one and put it into the southeast model. And we should be able to just change the name to, actually, I'm not just going to change, I'm going to change that like that, all caps. And this one needs to be DS1. And then we can, and I also want to turn the channel off because my channel's not ready to go. My channel isn't ready yet, so I want to turn the channel off. And so I'll do that here. And then this one is ready to run so that we're getting the inflow from the north and the south, and from the north and from the southeast. So I'm going to let this one run. So what this is giving us now is, I'm going to show you right here. This is taking the rain on grid, the inflow across the boundary, computing the flow across into the downstream boundary to get the inflow node for the downstream boundary. So then these inflow nodes will just have to actually add to the other ones. So that's why this is overly complicated. I think in retrospect, I would probably have done this differently so that you would have, you know, a system that wasn't so challenging. I don't think I would ever split up a domain like this in real life. But it's okay because we get to see this whole process. So I guess it's good. So now I'm guessing what we're going to have to do is just run this. And this takes like what, 20 minutes to run, but it's going to take longer because it's now calculating the water across, you know, to feed that domain, which actually doesn't really apply until the end when it's doing its post-processing. I don't think it has anything. It doesn't really capture anything until the very end. So this is like a 20-minute model. This one is like, usually this one takes about 0.3 hours. So this one takes about 20 minutes. This one takes about 15 minutes. And then the other one, it'll really take even less time now because I've split it in half. And then the last one will take about 15 minutes. So now what we see here is the inflow ds1.dat is what you should see in here. Wait, let's make sure our outflows, yeah, we got them. There's our outflow boundary right there. And there's our inflow, our CAD points underscore DS1. So when this stops, when the water starts to cross that boundary, that will be written as the inflow for this. And then we'll actually, or sorry, for the southwest, and then we'll actually have to copy that into the file. Silly. So let's get that one ready for southwest. Yeah. And we do not need, I'm going to just rename this one a little bit just so that we know that we're not actually using that one. And we'll turn off the channel on this one too. We'll do the channel next week. And then once this one's done, we need the inflow node out of this one to feed to this one. I kind of thought we'd see that by now, but maybe not. And let's see how far along it is. Yeah, it's only an hour. I was just going to let it run for 2 hours, and then we'll just see if we can get anything out of it at 2 hours. And this, you can see that this is why I don't run these with like the full 24-hour hydrograph, because it just takes a long time. So there's no sense in wasting your time with a full, you know, you're just to get the connectivities correct. And you know, if you put infiltration and stuff in there, it just takes that much longer to run it. I don't think I'm going to have any inflow at an hour and a half. I think I'm going to need to run it a little bit longer. I might have messed it up though. I was kind of expecting to see that inflow DS1 already. So I'm hoping I didn't mess it up. Well, let's assume we get a little bit of inflow. I'll exit it here just so we can get some input and see what happens. Well, we did get some up-down connectivity. That's good. And we did get some inflow. Okay, good. We got a little bit of inflow. That's all we need. Okay, so this is finished. Let's go ahead and close it. And then once that's finished, you'll see that that fills up. Now, of course, this is not exactly good because I only ran it to an hour, but that's okay because what we're really interested in is just the process, okay? So now what we'll want to do with this is we can't just put this file into the downstream model because it already has an inflow.dat file in there. So let's go to the downstream model for a sec. This is our Southwest downstream model. And I didn't mean to do that. I meant to do that. Okay, and we want, this is our Southeast upstream model. Here is the inflow.dat from that. And I just want to take these lines. So I'm just going to copy these lines, Control Shift End, and copy. And then what I didn't want, I don't want that first control line, right? Because it's already in there. It's already in the other one. So I copy that and I take it into the Southwest model and I go end, or no, control end. Oh, these are all the empty ones. That's not right. These are the ones that didn't have inflow hydrographs. They shouldn't be in there. I'm gonna have to tell Noemi about that. That's not right. Oh yeah, there's a bunch of them. Interesting. Yeah, those shouldn't be there. Oh, you know what? That could be from, shoot. That could be from no, it can't be from QGIS because that's an, okay. Ah, that's odd. Huh, something weird there happened. So maybe they didn't get any water yet. Let's make sure that, yeah, something definitely weird. I'm gonna have to check on that. Okay, so all of these have water. It wouldn't be, it wouldn't be printed if they didn't have water. And they all have an F, and they all have water. So that's good. And then you save it. But what's not good is why did my other inflow.dat have all those blank F lines? That's not right. So I'm gonna get with Noemi about that. So check on that. And then we'll hit, it could have, yeah, we'll hit the engine. And then what we're going to do now is we're just going to run this just to see that it runs. And it runs. So that means that at least the data is in there correctly. But I'm going to check out one more thing. I'm going to check out this inflow.dat because I want to see. Yeah, I don't see any blank F lines here. So that's good. And that doesn't matter. It can just be left alone. Okay, so I don't know. I'll talk to Noemi about this and try to get some ideas about what's going on with that. And then I'll get back to all of you when I next week when all these are run, when we have them all run to 10 hours, and then we'll check out just how to set up the channel so that the channel also crosses the boundary. So that's basically it for this week. And we'll go over this again because that got confusing because I messed up those two. So thank you for your time. Thank you for bearing with me on this one. I appreciate that. Hopefully next week we'll have everything kind of squared away and I won't be confused about things. We'll get it all done. So we'll see you then.